So now we introduce a third state element, which is the D latch. D stands for data. So D is data. And this circuit element has two inputs, clock and D, and stores 1 bit of state. So clock controls when the output changes, the output Q, and D, the data input, controls what the output changes to. And so the way this D latch works is it's actually built on top of an RS latch or an SR latch. And so we have our S and R inputs and our Q, our state bit output. And now we have AND gates that precede these this SR latch. And so we tie these AND gates to the S and R inputs, and then we AND them with clock. We put a clock input into the AND gates. And so when clock is equal to 0, it doesn't matter what's on the other input of this AND gate. When clock is equal to 0, 0 and anything is going to be 0. So S and R are going to be 0 when clock is 0, and we know that when S and R both have zeros on their inputs, then Q just retains its previous value. So then it's in the memory state. So now let's see what we put on the other input of those AND gates. So now we have D, this data input that goes into this top AND gate. So D, our data or our value that we want to store into that state element, into this D latch. And we put D bar into the other AND gate that feeds to R. And so here we have our D latch. So what happens when, we saw what happens when clock is equal to 0. When clock is 0, no matter what, right? It doesn't matter what D is, 0 and anything on this gate, on those AND gates. The output is 0, and the SR latch just stores whatever it had before, right? Q equals Q previous. But now when clock is equal to 1, let's see what happens. So when clock is equal to 1, well, now we have 1 and anything on both of those AND gates. So now it depends on what D is. So 1 and anything, right? This is just 1 and D, which is just D, right? So D comes out of this gate and goes into the S input of the SR latch, and this is 1 and D bar, so 1 and D bar is just D bar, feeds into the R input of that SR latch. And so here we have, let's think about what happens when D is equal to 0, or let's start when D is equal to 1. Well, then set is 1, the set input of the SR latch is 1, and reset is D bar or 0, and the output Q sets to 1. And so when clock is equal to 1, D just essentially flows through to Q. Let's do the other case to make sure. When D is equal to 0, right, here's our other case. When D is equal to 0, well, S gets 0, the S input of the SR latch, and the R input gets D bar, which is 1. And then we know that if you have a 1 on R and a 0 on S, then the output Q resets to 0. So in fact, when D equals 0, the output Q, that state bit, follows D. And as we saw before, when D was 1, the output Q also followed what D did. So essentially when clock is equal to 0, it just retains its state. When clock's equal to 0, this D latch, right, if we now enclose this into a larger box, this D latch retains its state. When clock is equal to 1, however, D just passes through to the output Q. So here's our symbol for this D latch. We have a D input, and we put our clock input on the top because it's a control input. It's controlling when D can pass through to Q. So when clock is equal to 1, D just passes through to Q, and we call the latch transparent because D can see through to Q. When clock is equal to 0, the latch is opaque and Q just retains its previous value. It doesn't, D can be changing all at once, 1, 0, but Q is just going to retain whatever it had last time clock was high. And it avoids this invalid case where Q is not equal to the inverse. Q and Q bar do not have the inverse relationship. So here's the D-latch internal circuit. Let's take a look. Well, now S is on the bottom, note, and R is on the top. But still we have clock going into both of these AND gates. We have D going into the AND gate that feeds to S, and D bar going into the AND gate that feeds into R. And again, here is our symbol for the D latch. And so when clock is equal to 0, D is a don't care, and D bar is a don't care bar. We don't care what D is because when clock is 0, we get 0 and anything on both of those AND gates. So R and S are both 0, and Q just retains its previous value, Q previous, and Q bar retains Q previous bar, whatever it had the last time clock was high. Now when clock is equal to 1, well, now it's going to just allow D to pass through, or D bar to pass through these AND gates. So when D is 0, we get 1 and 0, we get a 0, D bar would then be 1, right? 0 comes up here and gets inverted, becomes a 1, we get 1 and 1, R is a 1. So then we have D bar is 1, S is 0, R is 1. And so with a 1 on R and a 0 on S, we reset the output Q to 0, and Q bar is the opposite. And then we have the last row in the truth table when D is 1 and clock is still 1, right? When D is 1, D bar is 0, so we have D being 1, D bar is the inverse, 0, 1 and 1 on this lower AND gate, set input becomes 1, and we get 0 and 1 on the top AND gate. The reset input is 0, so we know that when we have a 1 on the S input of an SR latch and a 0 on the R input, the output gets set to 1. The state bit being stored is a 1. And so we see that, in fact, when clock is 0, it retains its state. But when clock is 1, the output just follows whatever, the output Q follows whatever D does. So it follows D.